will explain that uh, that assignment 3 we done. So I will just explain on my own word the assignment 3, what we're done so far here. So I will start the first question 1A, and after that 1B, and I will explain the process how we're done so far with my small comments. Okay. So for question 1A, I was asked to detect diagonal lines, right? This is the question actually. We're going to 85 degrees angle using convolution. To achieve this, I designed the following kernel. Well, actually, you design the following kernel here. And this kernel is specifically designed to instance pixel data line along a 45-degree direction. And I applied it an image of car using the custom conv to the kernel function, which you can see here, right? So as you can see, the result highlight features in the image that align with the 45 degrees direction. And for going the question 1B, the task was detect lines that are angled at 135 degrees, and the kernel you provide us here, right, 135 degrees, right, it's correct. So the output image clearly highlights the edges and patterns in the 135 degrees direction also. So we're going moving question 2A. So I applied a basic degree detection kernel. Well, I mean, you provide us again. So basically, this kernel detects diagonal and horizontal direction to the pixel instead of the result after the pixel instantly. So the result after applying to convolution looks like this. So it gives a clear outline of the edges in the image, which one here where I'm talking about. And then we're moving to A to B. So and again, another kernel you provide us, and also there is a question C. So I will talk about both. So let's say the both kernels actually, both these kernels actually are used to enhance sharp instability chains, helping identify edges more strongly. And the output will be each one, of course, as expected. The second Laplacian kernel produce a more pronounced admage, right? Like an admage, sorry, map. And then also both kernels are used to enhance sharp instability chains, helping identify edges more strongly, by the way. So we are moving on part B. So I'll just run the each code line. It's not gonna, it's work actually, because I run that before the other ones, the other previous codes, and that's why. And also this is running, it's gonna take a time a little bit, so that's why I'm just making a video. By the way, there is no error, everything's worked perfectly, by the way. So we are moving question 3. There we go. Question 3 to 10. So the question that did the network present signs of overfitting, if so, and which approach, right? So now I will say answer like this, kind of. So yes, the network shows sign of overfitting, and it ties that after around the approach 20 to 30, the training accuracy kept increasing, but the validation accuracy either stopped improving or slightly dropped. This is a classic sign of overfitting, where the model learns the training data too well, but fails to generalize to new data. And for question 4, so write down how many layers this model has and identify their types. So the original model has 5 layers: the conv 2D for extracting features from the image, max pool in 2D for reducing the size of features map, and flatten to convert 2D also data into a 1D vector, and then dense There's two dens, the one of the 128 neurons and another one the 10 neurons. So 128 neurons falsely connected layers with the real activation, and the 10 neurons output layers the soft max for classification. Sorry. So for question 5, is ask us briefly explain what is the purpose of each of those layers. So there's again gonna be like the five layers that we're gonna talk about: the convex, like conv-d2, the text patterns such as the ages of textures in the input image, and the max pooling 2D reduces this spatial dimensions and keeps important features, and the flatten the output of the previous layers into the 1D array, and the dense 128 neurons learns abstract features from the flattened data. And probably not, yes, the last one, exactly here. Right, so the last one, the 10 neurons, which is outputs class probabilities for final classification. And we are moving on question 6. So I added an extra column D2 layers to the model of improving its features exotic capability. So this helps the model learn more complex patterns. After that, I compiled and trained the updates model using the same training parameters and visualized the results. As you can see, it's just still running. It's gonna take a little bit of time, probably like 20 or 30 minutes still running. It's not done yet. So for question 7 also, we're going to say, right. So the compare performance before and after. So yes, so when comparing the performance before and after adding the extra column D2 layers, the train accuracy slightly improved, but like the model also became slightly more prone to overfitting. So I decided to apply regularization in the next step. Okay, and then question 8 is gonna be I added drop layers with a rate of 0.5 after the dense layer. So this means 50% of the neurons in that layer are randomly detected during training. So this helps prevent overfitting and encourages the model to learn more robust features, right? And after training the new model, I noticed the gap between training and validation accuracy became similar, which shows better generalization. And the question 9 is supposed to be here, the 8, 9, the last one here. And also there's supposed to be another one. Basically, a drop layers is used to prevent overfitting. So during training, it randomly turns off a certain percentage of neurons. So the network doesn't rely too much on specific features. So this forces the model to learn different combinations and make it more general at prediction time. So dropped is disabled and the full network is used to basically. And so this is the what assignment 3 we're done so far. Thank you for your time. Thank you for watching me. And also additional, I just want to say the compare models again for 10. By the way, just don't want to miss it. So that when comparing the model with the wrapped, like to the one without, the validation accuracy improved slightly and overfitting was reduced. So this shows that add and dropout help the model generalize better on unseen data. Okay, so I just wanted to add that part too. So thank you for watching me. Thank you for your time.